Today we're going to talk about something important and maybe a little uncomfortable. The Model Context Protocol does not make your AI applications secure. And a lot of people are finding this out the hard way. Model Context Protocol, or MCP, is awesome. It connects AI agents to tools, data sources, and APIs. Basically the USB-C for AI. But MCP is essentially a plumbing protocol. It standardizes how things connect, not whether they should connect at all. And security, well, MCP leaves that part to you by design. And if you look at the number of data breaches in 2025, this suggests that many people aren't really getting this right. Here's the thing, MCP's own spec is super clear about this. Authorization, that is actual permission decisions, is described as optional and strongly recommended when your server accesses user-specific data. Optional, strongly recommended, not enforced. The spec walks through all of the authentication mechanics. You have OAuth 2.1 flows, token validation, protected resources metadata. And a big update in November 2025 added even more. OAuth client ID metadata docs, incremental scope, consent, and OpenID Connect discovery. All of it great. But here's the catch. These features only prove who a user is, that is identity, but they do not define what the user is allowed to do, that is permissions. MCP defines servers as OAuth resource servers. They validate tokens, they check scopes, but what those scopes actually permit, well, we don't know. What tool can a user call? Which resources can they touch? That's all on the side of the person implementing this MCP server. And server builders and users have to get this decision right, and historically, well, they haven't. Let's look at a bunch of breaches from the recent past. There were tool poisoning attacks against WhatsApp. There were prompt injection exploits against GitHub's official MCP server. There was cross-tenant data exposure in Asana. There was remote code execution via MCP Remote, and that one had about 437,000 downloads. And there were also supply chain compromises in hosted MCP registries. And none of these required some elite zero-day exploit. The common cause for all of this was authorization failures, overprivileged tokens, missing access controls, inadequate isolation. You see the pattern. And even if implementers were perfect, and say the users reviewed every permission carefully, there's a deeper structural issue right here. In fact, Simon Willison, the co-creator of the Django web framework, calls this the lethal trifecta for AI agents. Here's the scenario. If an AI system has access through three of these things, attackers can steal data with almost no effort. They are 1. Access to private data, 2. Exposure to untrusted content, and 3. External communication abilities. Sound familiar? Well, MCP actually makes it really easy to assemble this exact setup. MCP makes it easy to accidentally create this combination. You connect a document server for search, you add an email tool for sending summaries, you enable web browsing to pull in external content. Each tool seems reasonable in isolation, but together they form the conditions for this lethal trifecta and for data exfiltration. In fact, the GitHub MCP breach proved exactly this point. Their MCP server had a single overprivileged personal access token. One token that let a prompt injection in a public issue leak private repos, salary spreadsheets, and internal files into a public pull request. There was no malware, no credential theft, just simple instructions written in natural language. And once this private data hits the model contexts window, it's game over. You can't put that toothpaste back in the tube. And this is why precise authorization matters. Controlling exactly what enters this context window and enforcing permissions at execution time, not just at the session start. Don't forget to subscribe to this channel for more content on authorization, but now back to the video. Some teams are trying to solve this by adding more AI. You can train a model to detect sensitive content. You can add an AI layer to monitor other AI systems. Is this helpful? Sure. Is this sufficient? Nope. Because generative AI is inherently probabilistic. You can have a 99.9% accuracy rate, which still means plenty of failures at scale. And security decisions, real authorization checks, can't be probably yes or probably no. They have to be deterministic. So AI can assist security, but AI cannot be security. Now, to be fair, MCP itself isn't broken. It solves a real integration problem. This ecosystem has exploded in the past year. There are more than 2,000 servers in the registry. There's official support from GitHub, Stripe, Notion, Hugging Face, backing from all of the cloud giants, and everyone and their grandma right now has an MCP server. But the community knows that authorization here is a gap. You really need authorization infrastructure that evolves as fast as your AI use cases do. And this is because AI doesn't create new authorization problems, it scales them up. Because suddenly you have more actors. It's not just users, you have agents, tools, services, and more. So what you need really is a permission model where agents and tools are first-class subjects, while you can do low latency, high volume authorization checks, and you can adapt without code rewrites or deploys. Let's quickly wrap up before something again changes in the world of AI. If you're building an AI app with MCP or agents or even a RAG pipeline, take authorization seriously. Don't assume that a protocol protects you automatically, because in lots of cases it doesn't. But the good news is, with the right infrastructure, you can actually build secure, scalable AI systems. Don't forget to subscribe to this channel for more content on authorization, and I'll see you in the next one.